We're going to learn our final method of how we can solve systems of equations. The third and final method is solving by elimination. Okay? So I asked you to simplify these expressions. And what happened in number one? What happened when you were simplifying that four-term expression? Share with me what happened, Tyler?
Y would cancel out.
The y's canceled out. In other words, when you combine those terms, because what relationship do they have to each other? They are, first of all, what?
Both Y's.
They're both y's, so that's considered what? When they're both y's, what do we call them?
Like terms.
Like terms. Okay, so they're like terms, first of all, so we can bring them together. We can say they can be added together. And then, what relationship does 2 have to, if I change this to add the opposite, it would really be plus a negative 2y, right? What relationship do 2 and negative 2 have to each other?
Opposites.
They're opposites. And when you add opposites, what happens? It becomes 0. So we really end up with 0 here, or 0y, right? And 0 times y is still what?
0.
0, okay. And then, what else happens?
5x and x.
And then the 5x and the x, that is the third term, they can be combined, and what do they become? 6x. Okay, so we have 6x plus that 0. And 6x plus 0 is 6x. So what ended up happening? What eliminated? The y's eliminated, didn't they? Okay? How about what happened in number 2? Anything eliminate there? But the first thing you have to do is what in this one? There's more than one simplified step, not just combining like terms, but what else do you have to do? Distributive properties. So you gotta do this distributive property first. Good. And when we distribute 2 over x minus y, what do we get?
2x minus 2.
2x minus 2y, okay? And then we have minus 2x and plus 7y. So what ends up happening this time?
The x's get canceled.
Yeah, the x's end up, they're like terms, and this is really a added opposite. It's really a negative 2x, so these guys are the ones that become 0 this time. And negative 2y plus 7y, can we add those together? Of course we can, they're like terms, right? So we can add these guys together, and what do we get? 5y. Those guys can be brought together, and 0 plus 5y is 5y. We don't need that 0 plus there. So this time our x is eliminated, because they have coefficients on them that are called what? What is a coefficient? Oh, maybe I just threw out a little bit.
That's the number in front of the variable.
Yeah, the number in front of the variable. So the x's have coefficients that are what? Opposites of each other. Yeah, so when we add opposites, we get 0. So that's what's going to happen today. When we're solving by the elimination method, our goal is to get one of the variables to eliminate. So we're going to use this method to help us solve when the equations are in standard form. What's standard form? What's that look like? Y equals or x equals, is that standard form?
It'll be like 2x plus 5y equals any number.
Okay, 2x plus 5y equals, pick a number since you picked
7.
how many x's there are going to be, how many y's there are going to be, so okay, that. So 2x plus 5y equals 7, that's an equation in standard form. Do you agree? Oh, like, is this the first day you've heard about standard form? Kind of looking like it.
Standard form is simplest you can have.
Standard form is what?
Most simplified.
Most simplified? Well, typically, you know, kind of depends on what you want to use it for. We might consider slope-intercept form the most simplified if we want to graph it, right? If we want to use the graphing method, don't we want it in slope-intercept form? Isn't that a handy form to have it in? Yeah. But if it's in standard form, there is actually a algebraic model for that where Russell picked how many x's he wanted, he picked how many y's he wanted, and he picked what he wanted the constant to be. Here's standard form, and I want you to write it in your notes. Capital A, little x, ax, a being the coefficient on x, plus what? Anybody? B, capital B, y equals capital C for the constant. Yeah. A ax plus by equals c. That's standard form. So when the x's and the y's are together on the same side, the constant is on the other side, we have our equation in standard form. Well, when they're in standard form, and not until they are, if the x terms are opposites of each other, like happened in number 2 above, right? Weren't the x terms opposites of each other? Or, notice it says or, not and, it says or, the y terms are opposites of each other, which is what happened in number 1 up above. The y terms are opposites of each other. So we're going to look for opposites. Either can be either the x terms, the a's can be opposite, or the y terms, the b's can be opposites. And if they are, we're going to just go right to adding the equations together. We're going to add them to each other. So we're not going to do any solving here. We're just going to do some, what should we look for when we look at equations in a system of equations? First of all, 3x minus 4y equals 12. Is that in standard form? Yeah. It's really 3x plus what? Negative 4y equals 12. And 2x plus 4y equals 13. That's standard form? Yeah. So if they're both in standard form, now we can look at it and say, are either the x terms opposites of each other or the y terms opposites of each other? And in this case, are either of them? Which ones? The y terms are opposites of each other. When we look at those guys right there, we can see we have a negative 4y, we have a positive 4y. They're b values. Those b values are opposites of each other. So the y terms, negative 4y and positive 4y, are opposites. This would be a good one to use our elimination method for. How about the next system of equations? First of all, first question, are each of the equations in standard form?
Yes.
Yes. And do we have any opposite terms? The which ones?
X.
The x terms are opposite this time. Positive x and negative x are opposites. They cancel each other out if you add them together, right? Or they end up with 0. Okay, so first thing you got to do is you got to look at the equations. You got to decide, are both the equations in standard form? And if they are, do we have any opposites? Are the x's, are the a's opposites? With y's, are the b's opposites? And then we can go to setting up an addition problem if they are. So let's go to the backside and practice a couple of these. Let's solve by elimination. 3x plus y equals negative 2. Negative 3x plus 2y equals 14. First answer this question for me. Now we know after today, we're going to know 3 ways to solve. How do you feel about, would this system be would graphing be a good choice to solve this system of equations? Do you want to work that hard? How do you feel about that? Because they're both in standard form. Is standard form graphing friendly form? Not necessarily, no. Okay, how about substitution? What do we look for in substitution? Right away we look and we say, if you just did a couple days worth of it, seriously? 3 days worth of it. If one of the equations is set equal to x or y, then this is a good system to solve by substitution. Is that the case here? No. Neither of them have x or y by themselves. If we weren't going to learn this method, we would probably take the first equation and solve it for what? For y, and we would use the substitution method. Well, let me show you what's going to happen when we use a new method called the elimination method. We have x terms that are opposites, so they should eliminate. So we're going to set up an addition problem. Notice what I did. I have the first equation written, and right below it, lined up so nicely in columns, are like terms. When they're in standard form, the x's line up vertically, the y's line up vertically, and the constant lines up vertically. And we can put an addition bar under it, and we can add them together. So what happens when you add 3x plus negative 3x? 0. So let's just do this. Let's just say they cancel each other out. You can put your 0 there if you want. What happens when you add y plus 2y? It's a positive 2y, right? 3y. That becomes 3y Bring down our equal sign, we don't add our equal signs together. And negative 2 plus 14 is 12. Well, we got one basic step left. What is it?
Divide.
Divide both sides by 3. So 3y divided by 3 and 12 divided by 3. What's our y value? 4. Isn't that slick? We didn't have to work very hard at all, did we? Sure a lot easier than putting in self-intercept form and having to graph them. Sure a lot easier than having to solve that first equation for y and doing a substitution step. That was painless, almost. And then what are we going to do? Are we done? Of course not. We have to substitute what in for y into 4 in, look at what, and would you circle this? This is important that you understand. It does not matter which equation you use. You get to pick. You can use one, this person sitting at the same table as you can use the other. We would still get the same x value in the end. So, somebody pick for me. Which one do you want to use? Top one? Okay. 3x plus y equals negative 2. Boy, after looking through some papers last night, oh, some of you are just all over the place with your work and it's hard to follow. I don't even know how you follow it. So what are we going to, what happens when we put in 4 for y? We have an equation to solve for x. This one is actually going to take more time than step 1 this time. So go ahead and get it solved for x. I get negative 2. How about you? What you got? 9 1 2 3.
Oh, I just divided the last part.
So notice what it says. Okay, we got to write it as an ordered pair, but then notice what it says we're going to do in our homework.
Check.
We're going to do check problems. Well, how many problems do you have to do? A whole 6. Look at how easy this was. Any whining really going to happen?
Maybe a little.
Better not. Maybe a little, just because you got it when you're a 9th grader. It's just part of the deal. Okay, so let's go over here and let's do a check problem. When you check, do you get to say, well, I like the first equation, so I'm going to check it in that one?
Check
But
it.
you also have to
Yeah, you do get to say that, but then you also have to say, well, self, I also have to check it in the other one. So 3x plus y equals negative 2. That's one of the equations, so I'll start there. If that was our first one. So we'll sub in our negative 2 for x, and we'll sub in our 4 for y. And here's where I really started to lose it looking through your assignments. People went now from that to what? Check. Or they might have even, said negative 2 equals negative 2 check. No, you can't. I'm not letting you do that tomorrow. I want you to process this down. What is 3 times negative 2? Negative 6. Bring down the plus 4. Bring down the equals negative 2. And then we don't still put a check mark. What do? We say negative 6 plus 4 is negative 2. And then we can say check. Now, when you look at your paper, some of you, even if you've got a stamp, sometimes I might put, when you somehow or other manage to say that 10 plus negative 18 was 7, because the other side was 7, it was supposed to turn out that way. So you put 7 equals 7, check. You might see something written in your paper like, really? Well, who are you trying to get? Guess who? Guess who? Just you. You didn't fool me. So, if they don't check out, what are we supposed to do? Yeah, restart. Go back and find where you made your mistake. There's no, like pretending you made it. Got it? 3x plus 2y equals 14. You're probably already done, huh? And 4 goes in there. Three times -2? Did I do that right? It's supposed to be a -3x?
Yeah.
Yeah. -3 times -2?
6.
6. I had the wrong equation there. I forgot my negative sign on my 3x. And then plus
8.
2 times 4 is 8. Bring down my equal sign, bring down my 14. 6 plus 8 is? Because we want it to be or because it really is?
12.
Oh, okay, I'll take that. 14 equals 14. We do want it to be, and it really is.
I'm so confused.
Confused about what?
I don't know, I thought someone said 12.
Oh.
Well, London did, but then someone else, somebody looks back at me.
And somebody agreed with her?
Yeah.
Okay. Well, I think 6 plus 8 is 14, because it really is. What plus 8 is 12? 6.
Wait, what?
4.
Come on, you silly geese.
What plus 8 is 12? 4. Yeah.
Well,
Oh,
not 4, 6.
okay.
Oh my.
This is why I'm confused.
Okay, again, let's move on to the next one. What's the first thing we're going to look for? Are they both in?
No.
Are they
Yes.
both
Standard
in?
form.
Standard form.
Yes.
Okay.
Mhm.
Do we have any opposites?
Yes.
Okay, so then we can go right to work setting up our addition problem. We can go, I can add these guys together with a pen. I can use it with a pencil. I can add them together. So I put an addition bar and a plus sign showing I'm adding, and I say I'm just gonna add my like terms in vertical columns here. 3x plus x is
4x.
4x. This is a negative 4y, isn't it? Subtracting 4y is the same as adding a negative 4y. So what do we have when we add those y's together?
0.
0. They cancel each other out, don't they? Bring down our equal sign. 10 take away 2 is
8.
8. Well, this is almost feels like you should be able to, quit this class because it's so easy and move on to advanced algebra. You're ready.
I'm struggling.
Solving 4x equals 8? Okay. Do we agree that x is equal to 2?
Yes.
Okay, well, we got that. Okay, then we're going to solve for y. You get to pick which equation you want. I'm going to pick the second one.
Yeah.
It just looks friendlier for some reason. This should not be the part we struggle with solving equations at this point, right? One variable equations. It should be easy to us now. What's the right side become? -4. That's the right answer.
What is it?
And y equals what? -1. Or at least that's what we think anyway, right? Okay. So, what do we write? Ordered pair 2, -1, and then yes, we now check it to make sure. Just because we got nice integer values, we might be feeling pretty good about it, but there's no guarantee. There's some people who got nice integer values on their quiz, and they weren't the right ones, though. So I'm going to start with my first equation, which is 3x minus 4y equals 10. And I'm going to sub in what we believe the x and y values are. Three times 2. What's next? This is really, if we change it to add the opposite, this is a -4 being multiplied times a -1, so it is plus 4, isn't it? 6 plus 4 is?
10 equals 10. Check.
Okay, feeling good?
Check.
I'm gonna stop. I think I don't think I need to check it in the other one.
No,
You
you
should.
do. You should.
Thanks. Right answer. Don't you be being lazy, LeGrand. You do what you're supposed to.
Yeah, there you go. Confidence booster.
Lazy push tails.
True.
Two is 2.
I didn't.
4 times negative 1 is?
Negative 4.
Negative 4.
So 2 minus 4 equals -2.
So 2 plus a negative 4 or 2 minus 4 is?
Negative
2
equals -2. Check.
Check. Moving on. We're out of here.
Check.
That's your favorite thing to say, right?
Check.
Okay, and we got it? So when they are in standard form, elimination method actually turns out to be the most efficient one to use. And even though I'm gonna complicate it for you in the coming days, enjoy this. Yeah, before. Well, if you SQ3R, you know it's gonna complicate.
Is this gonna be on YouTube?
This is good.
We should stay on
Is
this
this
for
gonna be on YouTube?
Yes.
That's gonna be silly.
Yeah.